Environmental controls are a requirement of current good manufacturing practices. This control prevents contamination of products due to unsanitary conditions. In the risk management process, once risks have been identified and reviewed, environmental monitoring determines how effective controls are in place. According to ICH Q9, risk management is a systematic process for the assessment, control, communication and review of risks to the quality of medicinal products and patient safety. The application of risk management methodologies is beyond the scope of this lesson. However, you can learn about the principles of risk quality management during another Academy session. In aseptic processing, risk assessment needs to be conducted on the relevant locations, methods, equipment, and frequency. Continuous environmental monitoring is a program which evaluates the cleanliness of cleaning and disinfection programs and the operational performance of environmental controls. This monitoring should be performed to detect any potential sources of contamination. A contamination control strategy should be established to protect the product from microbial contamination events. Typical controls can be done at the level of facility design, building management, procedures, and personnel. Let's take some examples. In facility design, monitoring should be done cleanroom classifications, air quality including airborne particle monitoring, HVAC system, HEPA filters, first air, airlocks, surface finishes, lighting, and so on. In building management, monitoring should be done to check the movement of the airflow, pressure differentials, temperature, and humidity in real time. In procedures and trade personnel, monitoring should be done to minimize the risk of microbial contamination. Procedures and training programs should be in place so that aseptic techniques are understood and followed. These procedures should cover gowning, personnel flow, material flow, equipment flow, viable and non-viable sampling, reading plates, autoclaving, cleaning, and more. Single-use technologies is a specific technology that reduces the risk of contamination in biopharma. This technology is based on the application of disposable components instead of fixed pipings for fluid management made of stainless steel. Individual components are used, for example, sterilized connectors, tubes, filters, and containers. All these components can be combined to create a closed system. While steel components need to be cleaned after every batch, single-use equipment comes pre-sterilized and ready to use. One of the main advantages of single-use components is that autoclaving and other processes for sterilizing tubes assemblies are not needed. Another benefit is that this technology provides a streamlined process due to its flexibility and scalability. And lastly, there is a benefit of cost reduction in water, energy, and time. That's it for this session on how to minimize contamination in aseptic processing. Thank you for attending the course. I hope you found it useful and that you have learned a few things. See you again soon in the Academy as you continue your educational journey with Scilife.